Hello, everybody. This is Sunday. It's December 5th, and here we are moving into the final week of our online astronomy course. Wow, it's been a long time since we started all the way back in August, and you've learned an awful lot about the universe, about stars, planets, and galaxies. And today we'll finish it off. This week we'll finish it off with a history of the entire universe. But before we get to that, you might remember that last week I mentioned that you could go outside under dark skies and see the Andromeda Galaxy. Well, last week I was taking some trash out, and it was around 11:30 at night, and I opened the door, and oh my gosh, the sky was so dark and the stars were crisp and bright. And so I wanted to see if I could see the Andromeda Galaxy. So I went outside just in my driveway. I live up on the East Bench in Ogden. And, you know, the sky's not super dark because there are the city lights. But I just pointed the camera straight up because I knew that if I just faced west and looked almost straight up, I should be able to see Andromeda. And I took a picture, and this is what I got. And I'll just move aside here so you can see it a little bit better. You're looking up past my chimney. But if you take a look right here in the sky, there's this little fuzzy patch. It has a bright center. That's the nucleus of the Andromeda Galaxy. And you can see how it sort of stretches a little bit this way. And so that is our nearest neighbor, the Andromeda Galaxy. And if you're outside looking at that, and you might need binoculars to see it, but if it's really dark, you can see it with your naked eye. But you're looking at light that left Andromeda about 2.5 million years ago. So that was pretty cool to see earlier this week. And I also wanted to check out something else. And so I decided to just point my camera at a slightly different place. And here's what I saw. Now here, I took the photo, profile, not in landscape. So I'll have to move aside here so you can see the whole thing. But this is in my driveway, and our neighbor has this big garage, built a big garage. But if you look down low, and this is really cool, if you look down low, right here is the brightest star in the sky, and that is Sirius. And if you go up from Sirius, you find good old Orion right there. There's the 3 stars in Orion's belt, and over here is Betelgeuse, and down here is Rigel. And if you just follow the 3 stars in Orion's belt on up, you run into the Hyades star cluster. That's in the face of Taurus the Bull, and it's right about here, the Hyades star cluster. And if you go up from there, there are the Pleiades, the 7 sisters, so-called. And so, you might go out on one of these beautiful, dark, crisp evenings that we have in winter and take a look and find these stars for yourself. It's really great. But we're going to be talking about other things this week. And what we're going to be talking about this week, I'll bring up the background for that. And that is, we're going to be talking about the entire history of the universe. How did the universe start? Well, we don't know that exactly, but we know how it started, what it was like when it was very, 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 very young. And the study of the universe, the history of the universe, is called cosmology. And so we're going to be talking about cosmology here. And you already saw last week how all of the galaxies in the universe were expanding away from all of the other galaxies in the universe. And galaxies that are twice as far away from us are moving away twice as fast. You could imagine, suppose you had had your smartphone or something, you were taking from some cosmic perspective, you were taking a video of that. Now, suppose you reversed that video, ran it backwards. And so you would see everything moving toward each other. And things that were twice as far away were moving in twice as fast. And that means that everything would come together at the same time. And that tells you that the universe started from a very dense, very hot beginning. And that very dense, very hot beginning, the expansion from that we call the Big Bang. And so you can see that the Big Bang is not some idea that astronomers come out with. It's a direct consequence of the expanding universe. You just run the video backwards, and the universe must have started from a very hot, very dense beginning. So we should be able to see the remnant of the Big Bang. And if you ask where the Big Bang took place, the Big Bang took place everywhere, because all of space came together at that time. So everything was at the same place. So literally, you right now, watching me, are located at where the Big Bang took place. And so am I. And so is somebody in the Andromeda Galaxy. Because all of space was together for that brief, hot, dense beginning. Now, that turned out to be about 13.8 billion years ago. That's the age of our universe. And in the introduction to Module 14, you'll find out how that's calculated. But there must be a remnant of that. There must be some leftover sign from something that took place that was such a hot, dense beginning. And there is. And what you see behind me is a picture of the cosmic microwave background. The universe is filled with microwaves, and that is light that is left over from the Big Bang. And if you take a look at the pattern here of the blue and the orange dots are where the cosmic microwave background, it's black body radiation, so we can talk about the temperature of the radiation. The orange dots are where the density and the temperature was a little bit higher than average by about 1/100,000th of a degree. And the blue spots are where the universe was a little bit cooler than average by about 1/100,000th of a degree. And this pattern of bright and dark spots can tell us an awful lot about what our universe is like today. It can tell us what is in our universe. It can tell us how much of different constituents are in our universe. And those extra dense places, the orange spots, are where eventually matter fell together to form the first galaxy. And those first galaxies formed the first stars. And those first stars made within them the first generation of heavy elements, which went through further generations of stars, which ended up in our body. So the cosmic microwave background here is like the ultimate baby picture. But when the universe moved forward in time from the very beginning, when the universe was about 3 minutes old, that's where the first atoms came together, the first nuclei came together. At the beginning, all there was hydrogen. But in the first brief period of time, some helium was able to be formed. 4 hydrogen nuclei, 4 protons came together, boom, to form a helium nucleus. And that happened when the universe was about 3 minutes old. And also a few other elements were formed there, not very heavy elements like lithium and some boron, but all the rest of the heavier elements had to be made largely inside stars or by exploding stars that spread those elements throughout the universe. Now, when astronomers studied the expansion of the universe in great detail, they found that galaxies that were closer to us are moving away a little bit faster than expected. And that means that the expansion of the universe is actually speeding up. You might expect that, if there's a big bang and everything is moving away from everything else, that gravity would try to pull everything back together. And that's what astronomers thought for a long time, until the very end of the 20th century, when two teams independently discovered that the expansion of the universe was actually going faster and faster and faster. And this just amazed everybody. What could cause this? We don't know, but we do know that it does fit in with Einstein's ideas that describe the whole universe, that describe the science of cosmology. And we give the source of this expansion what powers it a name, and we call it dark energy. Now, dark energy, why is it called dark? It's because we have no idea what it is. We don't know how it works. Well, we do have some idea of how it works, but the predictions, if you work out the theory and you make a prediction about what you should see, the amount of dark energy that we predict is larger by a huge factor than what's actually observed. So there's a lot we have to learn about this process. But I told you that by looking at this pattern, we can figure out what is in the universe, what the constituents of the universe are. And if you analyze this pattern, it turns out you can learn several things. You can learn that the universe is about a little bit over 68% dark energy. 68% dark energy. It's about 26, a little bit over 26% dark matter. Now, dark matter, dark energy still have the word dark in them, but they're not related to each other at all. Both of them just signify, for dark energy, dark means we don't know what it is. For dark matter, it means it's not shining. About 4%, a little bit more than 4%, are dead stars. Dead stars, stars that have died, like black holes, neutron stars, white dwarfs. About half of 1% are bright stars. So half of 1% of all of the matter and energy in the universe is in the form of bright stars. So as astronomers, we've been fooled. Astronomers have been studying the pretty shiny bits in the sky. And it turns out that's only 1/2 of 1% of everything that's out there. Now, how far can we follow this process backwards in time? How far can we run the video back in time of the expansion of the universe? Well, we can reproduce the processes and what's going on in the early universe back to 1/millionth of a second, 1/millionth of a second in our laboratories. So we can recreate what the universe was like then. You can push it back with pretty good confidence back to 1/millionth of a second. But when you go beyond that, you're getting into unknown physics. And when you get back to a time called the Planck time is when we know our laws of physics are going to fall apart, because the very structure of space and time isn't going to be what it is today, at times earlier than the Planck time. And the Planck time is 10 to the minus 43 seconds. That's a decimal point. There's a decimal point, and then there's 42 zeros, and then a single one at the end. That fraction of a second is the Planck time. And at earlier times, we don't even understand what space and time were like. They weren't separated into a separate space and a separate time the way they are today. So we have a lot a lot to learn about cosmology. And one more thing, looking out into space, you might wonder if there's anybody looking back at us. You know, our sun formed fairly late in the universe. There could be life on other planets. There could be other civilizations. Now, life, I think, is fairly certain because life arose so quickly on Earth, as you'll find out. But to involve intelligence, I mean, we were stuck with dinosaurs for a long time before we involved with our big brains who could think and reflect upon ourselves. So intelligence may be a lot more rare than life itself. And in fact, you can even be optimistic and hope we're going to find signs of fossilized life, perhaps microbial life on Mars. But the search for extraterrestrial intelligence, the search for intelligent life, is still going on. That is called SETI, the search for extraterrestrial intelligence. And for a number of years, radio telescopes have been scanning the skies, looking for signals that are artificial in nature. And so far we haven't found them, but we've looked at only a small part of the sky, only within a very small range of frequencies. So the search goes on. So before I go in and show you Stellarium, let me remind you of what's remaining in the course. This is the last time I'm going to have to talk to you. So here's a final reminder that during this end of the course, from now till the end of finals, and end of finals is Thursday, December 16th, you have to do 3 things. You have to take the final exam, and you have to take the constellation quiz, and you have to do your signature assignment. You do all those on Canvas. The links for those are all on the same page that has the contents of the modules on them. It's down at the very bottom. And so please do all of those by the end of finals, and that is Thursday, December 16th. And you can start doing them anytime. Everything is now open. And so for the last time, I'd like to show you what's in Stellarium. So let me share the screen here and pull up Stellarium. There it is. Took a few seconds to get up. And this is taken around 6 in the evening. So it's fairly close to sunset. You can see we're looking south over here in the west. You can see that the still some glow from the sky. But take a look. Here is Venus and Saturn and Jupiter in the southwest. And what's cool is that you're going to be able to see the moon pass these up. Now, this is a very young moon. Here, I'll move it to the center. We just had the new moon, in fact, yesterday. And so this is what it's going to look like on the 7th. And the 7th is going to be on Tuesday. So if I take a look at the moon, I'm just going to zoom in on the moon and show it to you. You can see it's just a little sliver of a crescent there. So it's going to be a pretty sight. This is about as early as you can see the moon. And if you go night by night, you can watch the moon pass Saturn. Here it is on the 8th. This is Wednesday. And here it's past Jupiter by the 9th. And each night, the moon gets a little bit fuller and a little bit fuller. And of course, you can always look to the west. And if you look to the west this early, then Orion hasn't risen yet. So I'm going to change this to about 11 at night. And so if you see this at, if you're out at 11 at night, You can always see what I saw of the pictures I was showing you. I'll go a little bit more past 11, a few minutes past 11, because now Sirius is above the horizon. You can see what I was showing you in that image. In fact, I'll just zoom out so we can get it all on the same screen. There we go. You can see Sirius. You can go up, find Orion, go up from there, find the constellation Taurus with the Hyades star cluster, and go up from there to see the Pleiades. So a lot of cool stuff to see. Well, as always, if you have any questions about the final exam or the constellation quiz or any constellations about cosmology, you're always welcome to ask a question in discussions. You can send me an email. I can set up a Zoom meeting with you. Come see me in my office. And I hope you have a very successful end of the course. I hope you enjoy learning about this marvelous, wonderful, amazing story about cosmology. I hope the exams go well for you. I hope your signature assignment is easy. It should only take you about 10 minutes. And more than anything, I hope that after you go out, after the end of the semester on one of these cool winter evenings, look up, see the bright, crisp stars, and think about all that you've learned about them. So I will say goodbye, and I will wish you all a happy holidays. So bye-bye.